Good evening, and thanks for joining tonight's TI Technology webinar, hosted by Texas Instruments, where tonight we're going to take a look at IGDT. All right, I just got to do this with my kids. I can't say it. And with us tonight is Tom Reardon. He was on last week, and they invited him back. Crazy. And he's going to be with us again tonight. Tom spent many, many years in the classroom and now currently works for Texas Instruments in product strategy and development. And so I'm really excited to have Tom with us here tonight. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. So Tom, thanks so much for joining us tonight. I just see you popped your camera on.
Hi, Mike. How you doing? How's everybody doing? So this is our agenda. We're only looking at the TI-84 and TI-84 plus CE tonight as a tool for learning and discovery. You are able to do things with the Inspire, but we're not going to be talking about those, so I'm going to make sure that's clear. Over 25 creative teaching ideas from Algebra 1 through Calculus. You'll have access to all the 2-minute videos, student notes for each one of them, and teacher PDFs. Also we'll have a webinar drawing at the end. And I also, I'm going to be showing you the Halloween stuff at the end as well that I did last week. So back to you, Mike.
Thanks, Tom. We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Tom using the Q&A window on the right side of your screen. We'll also be using the chat window tonight to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. All right, Tom, feel free to get started and tell us what's with this crazy acronym that you created.
Okay, so you can see my screen okay? You good?
Yep.
All right, so I got to do this with my kids. 26 activities on the 84 and 84 CE. We'll include a 2-minute video for each one of them, student PDFs and teacher notes and solutions. And again, at the end, I want to show the Halloween files from last week because you can still use them until Monday and maybe even afterwards. And as normal, I do start off with a quote. I'm certain that students learn in more ways than I know how to teach. And this is just another way to get students to understand things. Let's hope anyway. So those 8 letters, I got to do this with my kids, is the acronym we're using for this. I was asked to come up with some clever ideas to use the 84, and I came up with, I think, 26 of them so far. So that's why this only applies to the 84 right now, but these are the topics, and this is the website where you'll get all the information. It is case sensitive, bit.ly/, those are lowercase, and the other ones are all uppercase. I got to do this with my kids, okay? So these are the topics, and I'll show that website again. In fact, Mike might even put that into the chat later on also. But let me just show you what that looks like live. So this is the website there. And the first link right here is the name and also the video. And all the videos are 2 minutes or less. Okay, that was the thing that I was told to do. Then there's a student PDF that goes with it, and then a teacher notes and solutions. So you've got all those things right there. Okay. Also at the end, there's a program that allows you to preload the equations and so on to quicken the experience. That is not a necessity, but it sure makes things a lot better, and you'll see that I'll be using those tonight. So with that, let's go ahead on to, now if I go too fast, remember you have videos to play at your own pace. So you can go back and say, you know what, he did it in 5 minutes, I need like 8 minutes, so you can. I'll be using, like I said, the program that just makes it more efficient, and hopefully you'll like it so much if you decide to use them, you'll use the program as well. So instead of typing in the window and what's in y equals and all this other good stuff, it presets it up for you. and you don't have to have them, but you're welcome to use them. So we'll start off with what I think is a very simple one, okay? Is the square root of x squared equal to x? Now, from my experience in Ohio, I'm from Northeast Ohio, and now I'm living in Columbus, Ohio. Um, Unfortunately, even with proper training, my students are going to go, yep, those are equal, okay? Those are equal. And so that kind of discourages me there, okay? So I'm going to go ahead and run up the program called I Got to Do This with My Kids, just so that it sets everything up for me. Oops. And again, this is, you don't have to do this on the teachers, the students' work there. It all shows you how to do this without using the program. I just prefer to do this. It is in set one. It is this one here, the second one in the list, but number 4 in the big list. So when I run that program, it resets my window the size I like. It puts into y equals what I'd like to see. So it's just all there for me. So now I'm going to go ahead and graph this. And some of my students are just flat out shocked that this is what the answer was, or this is what the graph turned out to be. Oops, wrong one. Um, and if I press trace, that even might be even better if I press trace, because you can see what I'm tracing on, the square root of the quantity x squared, okay? And you can see that that's not equal to that. But I've always told my students the square root of x squared is equal to the absolute value of x, and this kind of shows that much clearly. And unfortunately, my students would trust that black box more than it trusts me. So, but I'll take advantage of it. Okay. Now, another thing I would like to do here with this is I'd also like to change the mode to um, graph graph table, because I think it's a good idea to be able to see that. So I'll go down to full under mode and change that to graph table. And let me go to my table set and have it start at 0, a delta table of 1, and these are both on automatic. So when I press second graph, you can see that I'm at the origin in the table and at the origin on the graph. And I press the down arrow and it showed me I'm on 1, 1 and 2, 2. And that makes sense. 2 squared is 4. The principal square root of 4 is 2. So that makes sense. But when I go backwards, I go back up through to the negative numbers, you can see that this again, when I put in, let's say, -3, the quantity of -3 squared is going to be +9, and its principal square root is 3 as well. So I can see that, and I like to be able to have my students use the graph table when it's appropriate to use it. So another one that's very similar to that is this is the square. Oh, let me show them the PDF. Good thing I reminded myself of that. So there is a PDF of this one, and let me just show you that. So is the square root of x squared equal to x? So if you click on that on the link, here it is, and it just takes you through, shows you what window to have in there, how the grid lines should be set up, and so on. And then it's a very easy, quick activity. And then the teachers also have that as well. Okay, you have the teacher one, and I'll show you one of the teachers ones later. So going the other direction, what about the quantity of radical x squared? Okay, is that equal to x? And again, my students unfortunately are going to say, yeah, it's equal to x. And it's kind of true, but not always. And that's not good enough there. Okay, so if I go back and reset my table so that it starts at 0 and that goes at 1. And if I go to y equals, and this time I'm not going to use the program, I'm just going to type it in here and go left parentheses, the square root of x, and then get out from under the radical sign, quantity squared. And now when I press graph, some of my students will look at this and say, did he get tired? What's the deal here? Why is it like that? So if I go back to second table, so I can trace in the table, this part right here is exactly what my students thought it would be. But when I go to the negative numbers, look, I'm getting errors. And then now we would want to talk about why that would be the case. Okay. So remember, it's the square root of x. We're taking the square root of, let's say, -4. That's not a real number. So no matter what it is, we can't square it. Okay. And we're not talking about complex numbers here, just the real number system. So someone popped up domain issue, and that's exactly right. So we need to talk about domain and range and why those things are important. By the way, if you wanted to also just graph y equals x to see if they are the same, and if I wanted to, I could even make this a little thinner so that it shows up a little bit better when it's with the blue. So I'll make that a little bit thinner. And now when I graph it, it's pretty clear that they overlap in the first quadrant and at 0, but in the third quadrant, it's only on y equals x, and this one is not part of the domain. So there. So let me go back and go back to full mode on there. Let me stop and see if there are any questions or comments. Mike, anything I should be aware of?
I don't see any questions yet.
Okay, thank you. All right. So let's go ahead on to a few others here. Now, discover properties of inverse functions. That's something that I really like using technology to have my students understand this. And so these are the equations I would like to look at. So let me go ahead and again run that program. And this one is by the list, it's number 1. Okay, so that would be in set 1. So I'll press 1. And these are the ones on inverse functions. So I'll press this number 1 right here or enter. And now what it's done is it's already pre-populated the Y1, Y2, Y3, Y4. It set the window how I would like it. Everything's kind of cleaned up from whatever I've done before. Okay. So what I'm going to go ahead and do is, and I'm going, by the way, I'm going much quicker with this than I would with students. Okay. I'm just trying to show you how the technology is being used. I'm not teaching the whole lesson. So if I go ahead and graph these, at first you look, here's the blue, the original function, okay, y equals 2x minus 4. And then the other function is the quantity of x plus 4 all divided by 2. And one of the things I would want my students to notice is if I go down here at 0, -4, if these are inverses of each other, then if I interchange the x and y coordinates, it should be on the other one. So I'm going to jump to the red one and say, what happens when I go to -4? And it goes to 0, okay? And then if I trace the 0 here on the reddish brown one, it should be on 2, 0. So I'll go down here and type in 2, and it's 2, 0. And I can do that for a lot of them, okay, to see where that's the case. So I'd like them to investigate that. I'd also like to look at the table. So if I start at, let's say, 0, and I just go to the table here, on this one here, I can see that -4, 2, I'm sorry, 0, -4 is on the blue. And if I go up to -4, 0 is on the red. So here's 0, -4 blue, -4, 0 red. And then I can go through and do that with several other ordered pairs. So they can see the table, they can see the graph. But then I'd like to also show them, what if I do the composition of y1 of y2? So let me go ahead and graph that in green. And again, I already have that pre-populated so that students don't have to type it, though it might be a good idea for some of them to type it. That's up to you. So when I graph that, you can see I'm getting this line that hopefully they'll realize is y equals x. And if I graph going the other direction, y2 of y1 in pink, it traces right over that, which is a line y equals x. And so one of the things that I want them to discover is if two relations are inverses of each other, they are symmetric about the line y equals x. And if I compose them in either order, I get x also. Okay, so that's something I would like them to use the calculator or technology to see that. Again, I could also do this with numbers and say, how about if I do, let's say, y1 of alpha trace y2 of, let's say, It's 15 minutes gone by. Let's say 6. I get 6. And if I go the opposite direction, let's say y2 of y1 of that same number, 6, I also get 6. So not only do I get the same answer, but I'm getting the identity function. Okay, so all of these things that we talk about inverses and inverse functions and inverse relations, seems to come up here. And so I like to be able to see all of those things. So let me stop there a minute. Oh, yeah, okay, let me stop for a minute so far. And Mike, just let me know if we have any things I need to address.
Nothing yet. Just some
Okay.
positive comments so far about what people are seeing.
So that now I'd like to talk about how I wrote the functions. Okay. So again, this would be part of it as well. So in y1, you'll notice if I put in a number for y1, the first thing I do to it is put in a number, and I'm going to multiply it by 2 by the order of operations, and then subtract 4. If I put a number in brown or reddish brown, I put the number in. The first thing I'm going to do is add 4 to it, and then divide by 2 according to the order of operations. And so what you'll notice is these two right here, multiply by 2, divide by 2, are inverse operations. Add 4, subtract 4, inverse operations. And notice that they're done in inverse or reverse order. So I think it's another good thing to bring up to students so they can see that graphically, table, when I did y1 of y2, all those things I think need to play in here to talk about inverses. Similarly, we could also look at x squared plus 2 and the square root of x minus 2. So let me go back to this, and I'm going to go ahead and clear out what's there. Let me make this a little smaller at first. X squared plus 2. And here I'm going to do the square root of the quantity, x minus 2. And I'm going to turn off y3 and y4. So I don't want those to graph yet. Okay, and so let me go ahead and graph those. And we can talk about why that's not the whole thing there, and because this is not a function. Okay, if I extend this out, I could put that the negative square root of the quantity x minus 2 to get that, but I'm fine with that for right now. Okay, and again, I could also do like I did before, y1 of y2, y2 of y1 of the same number, show the identity function, and then if I graph the composition, notice I'm only getting part of it because of the domain issue, and we can talk about this. Why is the domain of the square root of x minus 2 2 and bigger? And that's also going to be our domain of our composition. Okay, so those are also some things you can start talking about with your students and get into some good discussions, I hope. Okay. But so I want them to see that. I want to trace and see the different ordered pairs, different orders, and so on, like we did before. And I'm not going to show that because I think you get the idea. But that gets me to this part again, which I really think we need to do more of this. And I don't think I did enough of it as I should have. Again, I'll input a number into the blue. I square it first, then add 2. And then in its inverse, I subtract 2 first, and then take the square root. And again, you can see that these are inverse operations. These are inverse operations, and we're doing them in inverse or reverse order. Okay, so I think that's kind of important to see that. So questions, comments, or suggestions?
Analogy could be putting on socks and shoes and then
Yeah, we had an analogy from Rebecca
Okay.
that you could be.
So this next one here, stick with me on this one, please. Okay. If you have any negative reactions, wait till the end. Okay, because I've done this with a couple different groups already, and at first they're going, I don't do this, but stick with me. I think you're going to like it towards the end. Okay. So one of the things that I always taught was I taught how inverse related using parametric equations. In fact, that's how I introduced parametric equations to students. And I think this could be used as a tool. I'm not teaching them parametric equations. I'm just using them as an illustrator. So let's go ahead and give this one a shot here. So again, I'll run the program because it's going to make set all these things up for me, put it in parametric mode and all that other good stuff. But again, if you don't want to use the program, you can just type in this information. So using parametrics is number 6 according to my list, so that'll be in set 1, and it's the 4th one down, inverses with parametrics. So if you look what happened here, if you go to y equals, you can see now we're in what's called parametric mode. My window looks like this, okay, with the t values, okay. And to graph the Cartesian equation y equals x squared minus 1, some of you haven't done this for a while or maybe ever done it, but to do this, I'll let x1 of t be equal to t, and then y is going to be t squared minus 1. And if I replace x with t, since they're equal, you can see why it's x squared minus 1. We'll go ahead and graph that. Okay, and so there's the graph in parametric mode. Okay. So now what I want to do is create the inverse of that. And I'm fine with it being a relation. So I'm going to go to y equals. And this is where I really go slowly, okay? So remember how you form an inverse is you completely interchange x's with y's. So since I want to have an x here, I'm going to put in what's y here. So that would be t squared minus 1. And then my y is going to be the x coordinate, which is just plain old everyday t. And when you're in parametric mode, that's where y t, it's x t theta n key, depending upon what mode you're in. So I'll get that. And so now I'm going to go ahead and graph the inverse of what's in blue and brown. And I get this beautiful looking inverse, but you can see it's not a relation, okay? And so when I can go ahead and press trace, so let me go ahead and press trace and let's go to 0, let's say on the blue one. So when I'm on the blue one, 0, -1. And if I jump to the red one, it's -1, 0. Okay. If I go to t equals 2, on the red, it's 3, 2. If I jump to the blue one, it's 2, 3. I mean, this is beautiful. I don't have to do a whole lot of working to do that. Okay, so I really like this idea of using the parametrics to see that we just interchanged ordered pairs. But the place I really like this is going to the table. So I'm going to go ahead to the table and I'm going to start at -5 and show every one. And this is all in the student and teacher one. But watch this when I press second graph for table and look at those ordered pairs. Compare the blue with the reddish brown. Every single one is just interchanged, which is exactly what we mean by an inverse. And somebody said beautiful, and that is my word exactly. This is beautiful. It's elegant. It's really teaches that idea, okay? And then if you go back to y equals, let's go ahead and graph the line y equals x to see that perfect symmetry about it. And the line y equals x, it's pretty easy to graph though. If you haven't done this in for a while, you're kind of stumped. All you do is put in t for each of those. So x sub 3 of t is t and y sub 3 is t also. So that'll be the line y equals x, they're equal. So now press graph and look at that beautiful symmetry. Look at that. Okay, just beautiful, just beautiful. So I really like this idea of using parametrics to teach inverses. I'm using it as a tool just like I use a calculator. Kids don't know how a calculator works, but they use it to learn. Kids don't have to know how parametrics work. They can just kind of see that. So hopefully that is something you thought was worthwhile. A few of you did seem to have some nice comments there, which I was glad to hear that. I do have on here to show you the student and teacher PDF. I think I have them here somewhere. So, whoops, not that one, not that one. Oh, I thought I did. Sorry, I guess I didn't have it. So let me pull it up. So this is inverses using parametrics. So this is the student PDF. And you can see it's similar to what I did here, okay, showing the graph and table and so on. Then I did another example, which I didn't do here, okay. But to see the teacher notes, just so you can see this, this is the teacher notes right here. You can see that I not only do I do what they say there, but I also answer all the questions, okay, that are asked. They're symmetric about the line y equals x. And all the screenshots are dropped in. And I should tell you that the student sheets are either one side of a paper or two sides of a paper, but the teacher notes and solutions could go on and on. So for example, this one goes on for 4 pages because I want to illustrate all these different things that we're doing here, okay? So hopefully this is something that you can use with your students. So what do you think? Does this help students understand better? You decide for your students. But I'm glad that some of you didn't turn me off right away and say, oh, you know, my kids can't do this, or I don't understand parametrics. You can use them. So glad to hear some of you thought that was pretty good. I do want to show trig inverses using parametrics, but I'm going to do it very quickly just to illustrate it, okay? Because I think this is how I taught it for years, and it really helped my students visualize better, okay? So again, let me quit. Since the last thing I did on the program was the program, I can just press enter, it'll run again. And trig inverses is number 7 according to the list. So that's still in set 1. And it's number 5 in this list. So here, what I've got is, this is the graph for the cosine of x, parametrically. So I'll graph that, okay? Now I'd like to graph, and what we would do is we would generate the inverse cosine function by doing the inverse cosine relation first. So if I go to y equals, again, I'm just going to interchange x and y, but this time I'm going to be a little bit more powerful. So for here, instead of typing in cosine of t, I'm going to type in y1 of t. So this is much more powerful. And for y2 of t, instead of being t, I'm going to type in x1 of t. And so now when I graph this, here's my cosine going the other direction, okay? I can also get the line y equals x by doing the t and t, like dynamite, t and t. See that beautiful symmetry about that, okay? I could do the ordered pairs, I could do the tables, do all those different things. I don't want to spend too much time on this, but here's the part I really like. Those of you who teach trig, where's the inverse cosine function? Well, I'll go back to y equals, and this is going to be in hot pink. So I want t for x, and the inverse cosine of t, which is second cosine of t, and that's going to be in pink. So here we go, watch. And there is that inverse cosine that has a domain from -1 to 1 inclusive and a range from 0 to pi inclusive. And I don't know how many of you teach that, but this is a thing of beauty right here. So in fact, let me pull that off. I think that's pull off a bowl. Here we go. There we go. All right. Now, those of you who don't teach trig or inverses or whatever, I'm going to go on to calculus, and I'm going to come back to algebra 1 and algebra 2, but I do want to get something for calculus because I rarely do things for calculus teachers, okay? But again, what I want to do is use technology to help me teach and help my students better visualize, better understand, you know, the whole deal, okay? So With this one, this is first derivative test. We'll look at relative extrema. We'll look at where it's increasing and decreasing. We'll also come to the halfway through. We'll also look at the second derivative as well. Okay. By the way, if you could put into the chat, if you think this is too fast or too slow, you know, if it's just right, don't put in anything. But if it's too fast or too slow, let Mike know in the task. Just could put fast or slow, and we'll figure out from there. All right, so this one here, again, I'm going to go back to running the program again because I don't want to have to type all this in and change all this window. And according to my list on my website, the derivative one is number 11. So I'll go down to set 2 because it's 8 to 14. And 11 is the fourth choice there. By the way, 4 and 5 are really the same. They use the same everything, okay? All right, so now if I go to y equals, you notice I'm no longer in parametric mode. I'm back in function mode. And I also actually updated this a little bit. I put in not only y1 typed in, but I also typed in the derivative function, okay? And for those of you maybe not aware that you can do that, let me just go ahead and type it in so you can see it. I think it'll be time worth spent to show you that. So if you want to take the derivative, you can take a derivative at a point, but I want to take a derivative of the whole function. So I'll go to alpha, I'm sorry, math, and number 8 is n derivative. And so it comes up with the derivative template. With respect to x, I'm going to take the derivative of what's in y1, and that would be under alpha trace y1. But here's the thing. I want it not at a particular number, but for all values of x. And so it's going to take that derivative. And so it's exactly what's in y2. So I'm just going to turn that off. And so now I'm going to graph this. You're going to see the original function in blue, the derivative in brownish red, and it'll take a little while because it's doing this point by point. Okay, so here we go. By the way, again, the window is set so that I don't have to preset that. Okay, so there we go. In blue is the original function. In red is its derivative. And those of you who don't teach this, stay with me, please. Okay. I think we're going to show you some things that you could apply that are not calculus. Okay. So one of the things that I would look at is where is the derivative 0? Okay. And I can see that its derivative is 0, the red, at -2. And at +3. And so I can go ahead and trace. I'm on the blue now, so I'll arrow down to the red, and I'll just go ahead and type in -2. And I can see that at -2, it's 0.000004, which for all practical purposes, 0. Keep in mind, it took the derivative point by point, so it's not going to be perfect, but it's close to 0. But also, if you look up at -2, if I jump up here on the blue function and go to -2, this is where the function has what's called a relative maximum, where the derivative is 0, which is not a surprise to those who teach that, but to our students, it's something we want them to start looking for. At +3, if I go back down to the derivative and go to +3, we can see that the derivative's value at 3 is also 0. And right below it is another critical number or critical point. So if I jump down here on the blue at exactly 3, my relative minimums is y is -138. Okay. So to help me see that, I'd like to actually draw vertical lines at those two places so that I could see that better. I'm going to use the inequalities app because the inequalities app has x equals in it. And this is where those of you who don't do calculus, you can use the inequalities app as well. So I'm going to go ahead and run the inequalities app. And notice when I go to y equals, Up in the upper left-hand corner is an x equals. So I'm going to go up to x equals. And I can go up to 6 different lines here, okay? So I think one was at -2, and the other one was at +3. And I think what I could do is set them off. Let me go over here, and let's see if we can make those green. Let's make them both green. And as far as style goes, I can't go any, I can only go bolder. I can't go dotted. I wish I could, but I can't. I'll just go a little bit narrow. And I'll go down here, press enter, and I can go through the colors here till I get to green and then make that thinner. And so now it's going to graph solid but thinner green lines where the zeros are. So I'll press graph. And I can see that right here, the derivative is 0. We have a maximum value on the blue. The derivative is 0. And at the same x value, we have a relative minimum value on the blue. And I think that's pretty good to see. It's nice to see that. It kind of sets it off. I'm using the calculator as an illustrator, okay? Now, the other thing in calculus, as those of you who teach it, note what is happening before I get to -2. You can see that the derivative is positive, okay? Would you all agree that this red function is positive? And if I look at the blue original function, the function in that same interval is increasing until I get to the -2 and then starts to decrease. So when the second derivative is positive, the function is increasing. Similarly, over here from x greater than 3, the derivative is positive. And starting here at x equals 3, the function is increasing, okay? And then between these two values, the derivative is definitely below the x-axis, so it's negative. And so the function should be decreasing, and it is, okay? It would really be nice if I could shade this, and that's what we're going to do next. And again, those of you who may not do calculus, you're going to want to use the inequalities app. So let me go back to y equals, and let me go back up to x equals. And instead of having an equal sign here, how about if I go back over here and change that to strictly less than? And when I change it strictly less than, it's going to show me dotted and then also shade. Okay, so I'll press enter twice. And I'll go down here and I'd like to also change that, but change that to be strictly greater than 3. Okay, and now let me go ahead and graph the function, the derivative, and now I can really see in this interval right here, the derivative is positive, the function is increasing. In this interval right here, the derivative is positive, the function is increasing. And in between, which I don't have shaded, it's actually like shaded in white, the derivative is negative and the function is decreasing. It really sets it off. But again, you don't have to using derivatives to use the inequalities app. You can use it from Algebra 1 on up. So let me pause there for a second and see, Mike, what questions we have.
I just think you you made some calc teachers out there very happy. So I don't see any questions, but lots of positive comments.
Good. How about, what was it, too fast, too slow? What was the thinking there?
I think we got one or two people that said that the pace was a little fast, but
A little fast. Okay.
a lot of people
Okay.
said that they can catch up on your website too.
Okay. Okay. Thanks
And
for
then
that
Josh,
input.
just really quickly, I don't know if you caught this or not, but Josh wanted to know if graphing x equals something is new or if that's been around forever.
As long as there's been an inequalities app, you've been able to do it. So it's been around for a long time, but you have to do it on the app.
This is good.
By the way, if you don't have an inequalities app, how I used to do this is I didn't tell my students this, but I would go down here. Let's do this in pink. Let's say I wanted to graph the line y equals 1. I would graph it as 1,000 times the quantity of x minus 1. And so watch, this will be pink. And it looks almost like a perfect vertical line because it's a line that's going through 1, 0 with a slope of 1,000. But we don't need to do that anymore because we have it. So, okay, well, I'm glad here we got some positives out of that because I was worried about doing calculus and doing inverses and so on. So glad to hear you like that. Okay. I think it's really a powerful, powerful thing here. As far as the second derivative goes, I'm not going to go through the whole thing on that because, but I do want to illustrate it. I did do it pre-did it here. So here, if you look here on my screen here, we have the functions in blue, the first derivative's in black, and the second derivative is the derivative of the first derivative, going to be in red, okay? And then I went ahead and just graphed the original function in blue and the second derivative in red, okay? And for those you teach it, I put in the inequalities and said, right here is where the second derivative is positive, and that's where the function is concave up, smiling. Here is where the second derivative is positive, and again, the function right here is concave up, smiling. And here the second derivative is negative, and the function is concave down or frowning. And then also what's really kind of cool is you can see where the points of inflection are. That's where the second derivative is 0 in this case. So here and here show me where the points of inflection when the second derivative is 0. And this just ties it all together. So for those of you in calculus, finally did something for you. Okay, hope. All right, this goes back to Algebra 2, maybe some Algebra 1, more Algebra 2, I think, or pre-calculus. Thinking of transformations as compositions of functions. So this one here, by the way, I have a program that I'm sharing with you on the Halloween stuff so that if you ever do stuff and you say, I don't want to reset my calculator, but I got just so much stuff in my y equals and everything's just, okay. I have a program called Reset Graph that brings everything back to how I like it. So if I go ahead and run that, okay, it clears everything out of y equals, puts the colors back where they're supposed to be, puts in my favorite window, has a graph screen with the grids, whole thing. By the way, I was using Inequalities app. I want to go back up now and turn that off because when I use it, I love it. And when I don't want to use it, it gets in the way. Okay. And so I know it's now gone because there's no x equals up here. Okay. All right. So I have a program called FOF Comp Y that I want to use, FOF for families of functions. And so go ahead and run that program. And it says transformations using composition of functions with the transformation app. Press enter to continue, going slowly, I hope. The parent function is in black and the transform function will be in blue. Right arrow increases the value of the parameter, left arrow decreases the value of the parameter. So it says run the transform app and press graph twice. So I'm going to go ahead and press the apps, and transform is usually the last one in your applications. So I'll press the up arrow to get there quicker. Press enter. And remember it said to press graph once, twice. And so it's showing me y2 is x minus c, where c is 0. If I go to y equals, in black, it's x squared, that parent function. And this is the composition of y2 of y3 of x that's going to be in blue. And right now, that's y equals x squared because c is 0, right? So I'm going to go ahead and increase the value of c one time. So I'm going to press the right arrow. And now c increases to 1. Notice the parent function is still in this skinny black. The transform function is y2 of y3, and this is x minus 1. I'll increase it to c equals 2, to c equals 3, to c equals 4, So somebody says, is that a slider? Yes, sliders are in the transformation app. Okay. By the way, if you're in a hurry, if I go to the left, it'll make it smaller, right? If I'm in a hurry and say I'd like to go to -4, I just type in the value that I want for C, press enter, and it'll take me there. But one of the things I would want students to notice is that the blue and reddish brown function always have the same y-intercept, okay? When I transform in this direction, they always have the same y-intercept. So now what I want to do is go back to y equals, and I'm going to do this in reverse order. So I'm going to change this to alpha trace to get the y variables and put in y3 on top of y2. Parentheses is fine. I want to put y2 on top of this, alpha trace y2, enter. And now I'm going to do the composition in a different reverse order, okay? So it starts off with C being 0 again, still the same. And now watch what happens when I increase C to 1 and C to 2, C to 3. And I'm going to cut to the chase here, but with students, we would take a while to let them play with this. But when I go in this direction, it's a horizontal shift. And when I went in the reverse order, it was a vertical shift. And notice now the vertex and the x-intercepts of both the blue transform function and the linear function, they have the same x-intercept. Whereas before, when I did differently, it was the same y-intercept. Y goes up and down, x goes left and right. And now we can start bringing in relationships and connections between transformations and what order we do them and the transfer and the composition of functions. So, and then also what's kind of cool about this is it doesn't have to be x squared. Okay, I can clear this out and type in second square root of x and graph it. And now I'm going to go ahead and decrease the value. And notice all I have to do is change what's in y3, and that will change the parent function. I can now make it, let's say, absolute value of x. And that's the beauty of this, is that we wrote it more generic, okay? And so now you can go ahead and see the absolute value and see how it shifts left and shifts right, and then up and down if you go in the other direction. So then I didn't see anybody ooh and on that one, but did anybody like it?
Received chat message from
Okay, we did have one,
I
so
liked it. So
thank you for speaking up there. Okay. All right. So that's composition of functions. There's a part 1 and a part 2. So one of the things that always got me was students really have a hard time when you have an infinite number of solutions for a system of equations. And so I don't think I did a good enough job with that. Okay. So again, I'm running transform app. Let me go ahead and turn that transform app off. And always want to quit it when you're done. So I'm going to solve this system here, okay? And to do that, you can solve a system using the app called Polysimultaneous 2. And number 2 is the simultaneous equation solver. And here I have a 2x2 as it shows here, okay? And then to go to the next screen, you press graph because it's right above the graph button. And so I typed this in already, okay, so that I wouldn't have to, you watch me do that, okay? But I typed in a -3rd x plus a half y and so on there. And now what I want to do is solve that system. So I'm going to go ahead and press the graph key to solve the system. And we're getting a really unusual looking answer, or at least it's unusual to my students, that says x is equal to 6 plus 3/2 times whatever y is, and y can be whatever it wants to be. And of course, that means there's an infinite number of solutions, and my students have a hard time with that. So what I'd like to do is show them ways of generating an infinite number of solutions to see what that means. So I'm going to go ahead and quit the app. And it says that x is found by taking 6 plus 3 halves times whatever y is. So a simple way to do this, maybe more with Algebra 1, is I could type in 6 plus, then get the fraction template by typing alpha xt theta n, 3 over 2, get out from the denominator, and then times, and the time sign is optional, but I like to put it in for emphasis. I'm going to put a list of numbers. And my list has to start, when I do a list, I have to start with curly brackets. So that would be second left parentheses to get the curly brackets. Let me make this bigger so you can see it. 6 plus 3 halves times curly brackets. And now I'm just going to type in numbers like 0, comma 1, comma 2, comma 3, comma 4, comma 5, comma 6. I think that's enough. Second right parentheses to finish the brackets. So what I'm saying is find out what these are when y is equal to 0, 1, 2, 3, up to 6. Okay. So press enter. And I love that it'll do this. So when y was 0, x is 6. When y was 1, x is 15 halves. So remember, the ordered pairs aren't 0, 6. These are the y's. These are the x's. Okay. Because this is x is equal to 6 plus 3 halves times y can be anything. So 6, 0, 15 halves 1, 9, 2, and so on. So here's some of the ordered pairs at work, but there's an infinite number of them. And to really hit them hard with that, I can go to an actual list and not, so let me go ahead and list one, put in like 50 numbers. Okay. So I'm going to go ahead and use the sequence command here that I'm going to get from the catalog. And I say, I want to create a sequence of numbers x, comma, x, comma, 1, comma, up to 50 parentheses. So this is going to give me the first 50 numbers, whole numbers. Okay. And in list 2, I'd like to put in that other thing, what was it? 6 plus 3 halves, 6 plus, and then 3 halves times whatever is in list 1. Enter. And now I have 50 ordered pairs. And for some of you might say, well, I don't like this idea because these are y's and these are x's. Could we get x comma y? And I'm going to say, yeah, we'll go over to L3. And I'm going to say, let's let L3 be equal to whatever is in L1 so that I can have x's in L2, y's in L3, and I've got 50 ordered pairs that satisfy that system of equations, and that's a small fraction of an infinite number of them. Okay, so again, that's in the in that activity there. I think that might, yeah, I'm not going to get to this one. We'll skip that one. But those, any of you do limits with asymptotes or limits at all, this is a really nice one there on that too. So didn't get to that. I did want to get to show you, since Halloween is coming up, and this is what I did last week, was Halloween ideas. This works on either the color, the 84 grayscale, or the Inspire color. And at this website right here, and maybe Mike can type that in for us, lowercase bit.ly/, and it's capital B, letter capital O, or boo, 2022 capital TI. And Mike got it in there already. Thank you, Mike. So if you go there, this is kind of what you'll get to see. I have programs that draw a ghost and a pumpkin. I also have on the color one, you can actually import. I have a pumpkin that you can import into the calculator and have your students draw a face. This is a face I use. You don't have to use this one. On the Inspire, also did some things here, but it tells you what functions to use. It has some templates, some things that you can use there. So hopefully you can use that. Let me see what that looks like here. So This is the I've got to do it with my kids website, the Boo website. Where is the Boo website? Oh, right here. This is Halloween ideas using the 3 different calculators. Let's say you have the 84 color. If you just click on that link right there, um, it shows you, you can download this whole thing as a zip folder, and then you can get the programs, you can get the PDFs. It's all there. There's the reset graph if you want to see the reset graph, and you really want that because these programs right here fill up all 10 functions, and you'd like that to be cleaned out there. Okay, so that's the uh, 84 color. The 84 grayscale is very similar, okay, and the Inspire is very similar also. There's only one file on the Inspire because everything can go in one document. TI Connect, you might need that to get stuff up there, and if you want to know how to use it, I created a short video to show you how to use TI Connect so you know how to get programs from your computer onto your calculator. And for maybe the first time ever, Mike, I'm finishing early, so I'll turn that back over to you. Let me put this, the websites back up again. I'll turn this back over to you.
Awesome. Thanks so much, Tom.
Polling panel is expanded. Received chat message from Annie Murray. So fun.
All right, so as promised, we are going to be giving away to one lucky winner tonight a TI graphing calculator of their choice. And tonight, I'm actually really excited. I'm always excited to introduce the winner, but tonight I'm especially excited only because I know that this one person has been attending a lot of our webinars over probably the past couple of years, and to my knowledge, I don't believe has ever won. So it gives me great pleasure to introduce tonight's winner is Myra Rubin. So Myra, congratulations. I hope you're excited about this, and you will be able to choose the calculator of your choice. And we'll be in touch, Myra, in next coming days to give you some information over email and to get some information from you as well. So congratulations. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents, and that includes my documents as well as Tom's. So Tom's Bentley is embedded in the documents that I'm providing as well. So there's lots of different places to get the documents from tonight. If you're missing these links for any reason or they're not working, just hang tight. You'll automatically get a follow-up email in a couple days. And then that follow-up email will give you a chance to watch this at your own pace with the recording, as well as download the certificate and download the documents as well. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. When we finish up tonight, if you need to get a hold of us for any reason, for example, earlier someone had asked about where or how to purchase the TI SmartView software, feel free to give us a call, 1-800-TI-CARES, or send us an email, ti-cares@ti.com. We have 2 more webinars in November, and then we're going to be finishing up for the fall season here. And we are currently working on the spring season, so your feedback is really important to us. It really helps guide our future online events, and we really hope you'll share your thoughts in the post-webinar survey. Huge thanks to Tom for everything I put together today. I know it probably only takes you like 5 or 10 minutes, Tom, to get a presentation, something like this tonight ready. It doesn't take long at all, I'm sure. I'm just kidding. I know that it took Tom probably hours to get everything ready for tonight. So, Tom, thanks so much for all the time that you spent getting all the videos ready and the links and all the documents. We really appreciate it. And thanks everyone else for joining us. We hope to see you back online next Tuesday. Have a great night.